Remember the oil crisis? While you may not, energy experts still do. And they're busy planning for more oil shortages in the future as the world's oil supply is slowly but surely used up. The search for renewable forms of energy has focused on everything from solar to ocean power. But power from organic material, from growing things, may hold the most promise. Processing organic material into usable fuel produces what is called biomass energy. It comes from burning, fermenting, or chemical extraction. The oil surplus of the last few years has made it cheaper to rely on oil than develop biomass energy, but now engineers are designing cheaper ways of extracting this green energy so it can compete economically with oil. The effort begins with the most traditional fuel of all. Biochemical engineering professor and amateur pilot Henry Bungay is working toward the day when alcohol made from wood and other growing things will become a vital energy source.
You get a real perspective on New York State when you're flying because you see the vast areas of forest in the Adirondacks. It would be quite easy to preserve enormous scenic areas and still have far more than enough biomass for our refining process.
In addition to his teaching responsibilities at Rensselaer Polytechnic Institute in Troy, New York, Dr. Bungay
To it is to refine the biomass and get everything. It makes no sense to try and run a refinery for only one portion of your starting material. For example, you wouldn't stay in the meatpacking business very long if you sold only steaks and threw everything else away. Some hardwood trees are acceptable in some grades of lumber and paper, but there are also some grades of hardwoods that aren't much good for anything. So if we can take these from our forests and derive benefit, we're essentially taking something which has little commercial value. And
Meanwhile, back at the lab at Rensselaer Polytech, researchers working with Dr. Bungay are looking for more efficient enzymes to make the process less expensive. In an adjacent lab, Biochemical Engineering Department Chairman Bruce Nauman's work takes him in a slightly different direction. He's using fermentation technology not to create fuel, but to find a substitute for plastics made from petroleum. His process, too, starts with wood and tiny creatures from nature.
Here's the fermenter. There are microorganisms in there. We grew them up. We fed them steak because they only grow on complex nitrogen sources, steak. But after a while, we turned off the steak and just fed them sugar, glucose.
The microorganisms turn the sugar into a chemical with new applications called butane-diol, a building block of plastics.
This kind of butane-diol can be turned into polyester. It's a kind of plastic that's used in clothing, it's used in car bodies. Our polyester, or the polyester made from this, would be different than any others out there.
On the drawing board is a pilot plant to produce butane-diol cheaply.
Then engineers have to worry about things actually happening. We aren't content just proving it's possible. We want to see it done. So engineers have to live with economics, and that's why we're looking at the economics as an integral part of this whole operation.
Doctors Bungay and Nauman say it's only a matter of time and money before the process developed in biochemical engineering labs will play a significant role in our energy future.
the energy problem is so massive that we have to look for as many solutions as we can. We've been just plain brilliant with our high mileage automobiles. We've put the OPEC countries right back on their heels. Without that, you can easily imagine the mess we'd be in. And the contribution